All right, so this is the table of values you should get. So for error, you could write error, undefined, just put a slash. There's just not a value when x is -1 and when x is 3. Okay, so there is one x-intercept. What is it? Yeah. Some people wrote it as -5, 0. I actually like that better. But I wrote it as x equals -5. Okay, so then the third part of this, I guess, is what do you notice about this value, -5, and the factored form of the function? Yeah, there is a x plus 5 factor in the numerator. And x equals -5 makes that 0. Or you could say -5 is a 0 of the numerator, because if x was -5, your numerator would be 0. Now, one thing that I do whenever I'm doing these problems where you factor is if there is a common factor in the numerator and denominator, I like to box it up. And we'll talk a lot more about that on Wednesday. But I'm boxing up the common factor. So that x-intercept one is not in common. So I'm just going to make a little note. It's not in common with the denominator. All right, and then number 3, what values of x is g not defined?
-1 and 3.
Good. All right, and we're going to go back and look at our factors. Do you see a 1 and 3 in the factors? Yeah. The denominator factors. So x plus 1 and x minus 3 are factors of the denominator. X equals -1 and x equal 3 makes those zeros. Making up words. So they're zeros of the denominator. So you guys already knew that if something makes you have 0 in the denominator, it's not in the domain, or it's undefined. So that's the reason why. And then number 4 is stuff we did last week. We did find y-intercepts last week just by putting 0 in for x's. This one's a little different because it's in factored form. Whoops. But basically that gives us -15 over -3 or 5, which is the same y-intercept you could get from the graph or from the table. Actually, it's not on the table. You could have got it from your table of values. All right, so I want you all to hold on to this paper. We are going to practice we're going to do the notes in a second, but practice some more of this tomorrow, but then we'll come back to that on Wednesday.
Thank you.
All right, so some of this is going to be repetitive from our last lesson because this is new stuff. So the more you hear it, hopefully, the more you'll remember it. But a rational function is of the form f of x equals n of x over d of x. So n for numerator, d for denominator. What type of functions are n and d? Remember, it starts with a p.
That starts with a what?
A p.
A P. It was the it's not the pepto thing.
No pepto.
Yeah.
Polynomial.
Yeah. What? I thought it was something different.
It's okay. They're polynomials. All right, so anytime, any function in the world, if you want to find the y-intercept, what do? Zero in for x. So the y-intercept is found by finding f of 0. So putting 0 in for your x. And we already did that. We already practiced that. Many other characteristics are revealed by factoring the numerator and denominator. That's probably going to be the most challenging thing for you today, is to do the factoring. But I could be wrong. You might be really good at it. And then anything that makes the denominator 0 has to be restricted from the domain. So all zeros of the denominator must be restricted from the domain. And then any zeros of the numerator not in common with the denominator is an x-intercept. Right. So right now, this looks like a whole bunch of words, but as we go through, we'll write some more notes. I think by the third one, you'll kind of understand what's happening. All right, so on example 1, we are going to find 4 things, 2 that are new today and 2 that we talked about last week. So domain is new today. So to find the domain in the x-intercepts, we are going to need to factor the numerator and the denominator. So when I look at the numerator, and there's only 2 terms, bless you, and I notice they're both perfect squares, so I just automatically think the difference of 2 squares, where you find each square root, and you put one with a plus and one with a minus. You guys remember doing that?
Yeah.
Okay, good. And then the denominator is just regular factoring, where we do our parentheses. What we put here and here needs to give us x squared, which obviously is x and x. And then we look at this sign. If it's a minus, these signs are going to be different. One will be plus and one will be minus. And then what we put here and here needs to multiply to give you 4, and then basically subtract to give you 3.
4 minus 1.
Yes. So I want to get a positive 3. So do I want the 4 to be positive or negative?
4 to be positive.
4 to be positive, 1 to be negative. Nice job. All right. So when I'm finding the domain, I only care about denominator. And your domain is going to be x does not equal. And then you basically just do the opposite. So in this case, it's going to be -4 and +1. Because if x was -4, that would make that 0. And if x was +1, it would make that 0. Yes, sir?
Is that a point or is that -4 and?
That is 2 separate numbers. Yeah, x does not equal -4 and x does not equal 1. 2 separate x's. All right. And then for the x-intercepts, we only care about the numerator. And then we want the factors not in common with the denominator. So what I would do, even though we're not really doing a whole problem today, if there is a common factor on the numerator and denominator, I would box it up. So when I say not in common, we're talking about outside the box. Outside the box on the top. And then we're going to do just like we did with the domain, except we're not going to have not equal to. It's going to be the opposite. So what do you guys think the x-intercept is going to be? 4. So outside the box and do the opposite on the top. It's a lot to remember, I know. All right, y-intercept we've already done. So y-intercept, we're putting 0 in for all the x's. And what I usually do is just cover up anything on the numerator and denominator that have an x. It leaves you with negative 16 over negative 4, or just regular old 4. All right, and then horizontal asymptote. Oh, I'm going to write a note that I didn't write. I recommend using original for the y-intercept and for the horizontal asymptote. Not the factored form. You can, it just makes it more difficult. All right, so for the horizontal asymptote, we look at the degrees of the numerator and denominator. What do you notice about the degrees? Same degree. Do you remember what to do for same degree?
If they were equal, they just equal y 0, right?
Nope, not y equals 0. It's okay though. You divide two things. No, right now they're the same. The leading coefficient. So you do leading coefficient over leading coefficient. So 1 divided by 1 or just 1. That's why we're doing that again today and tomorrow. Just so the more you practice it, the easier it's going to be for you to remember. All right, let's look at the back. So number 2's numerator it's not super easy to factor. So hopefully you notice that there is a common factor of x on that numerator. So that's the first thing I'm going to do up there is factor out a common factor of x. We're not going to be able to go straight to the answer. So when you factor that out, you're dividing by it, or you're like kicking out an x from each term. Now the denominator, I can just straight factor. It's the difference of squares again. All right, and then when I look at, to get x squared, obviously it's x and x. And then this tells you your signs are the same and they're both going to be plus signs. And then you want to multiply to get 9 and add to get 6. 3 and 3, yep. Okay. So remember, for the domain, we're talking about denominator only. And any x value that's going to make one of those factors 0 is not in the domain. So what can x not equal?
2.
4. Good job. Now, in the last problem and the one we did at the very, very beginning, we can box some factors up. Can I box anything up on this one? That's to be common in the numerator and denominator. I don't have anything in common, so that's fine. It doesn't matter. So when we're doing x-intercepts, we're talking about numerator only. And it's still not in common, but that's fine. So you can have multiple x-intercepts. This one has 2 x-intercepts. So we want to know what's going to make the numerator 0. What do y'all think? -3 and nope. 3 plus 3 is 6. What would make this one 0? That would put in for x and it would be 0. 0, thank you. All right. And then for the y-intercept, we're going to go to the original problem. We're going to put 0 in for all the x's. So what I like to do is just do that. So what does that leave you with on the top? On top is 0. So 0 divided by -4 is just 0. All right, and then for the horizontal asymptote, we're looking at the degrees. What do you notice? Numerator's bigger. So y'all remember?
Is this one? No, it's not this one.
This is when there's not a horizontal asymptote. So if the numerator degree is larger than the denominator degree, there's no horizontal asymptote. All right, one more. All right, that numerator on number 3, is there any way it will factor? It's already a factor. Like x minus 4 is as simple as it can be. So just leave it, x minus 4, and then you guys go ahead and try to factor the denominator on your own, please.
When you flip the signs, you're looking for the domains.
Yes. So when you factor the denominator, it should be x plus 2 times x minus 4. And the domain is going to be not equal to anything that's going to make the denominator 0, which, like he said, is going to be the opposites of those. All right, then if we have a common factor, we're going to box it up. So when we are finding the x-intercept, we're looking on the numerator outside of the box. Do I have anything? So what do you think that means? There's not one. Good job. So there doesn't have to be any of these things except for a domain. So every function has a domain, but it doesn't have to have an x-intercept or a y-intercept or a horizontal asymptote. So any of these can be none except the domain. All right, and then for our y-intercept, we're going to make all those x's zeros. And that leaves us with -4 over -8, or positive 1/2. And then for the horizontal asymptote, what do you notice about the degrees? The numerator degree is less than the denominator. So, Xavier, this is your time right here.
Y equals 0.
Yes. Wrong one. Sorry, I got 2. All right. Any questions on this lesson? Okay, we'll practice it tomorrow.